What's up everyone, Simulator Shane here. Today I want to show you some servo testing that I started doing on the bench. So what you can see in the screen right here is 5 volts coming from an iPod connector that's wired straight into a hobby servo there, the little black thing, and then there's a yellow wire going from the hobby servo to the Arduino, and that's the signal wire. The reason I'm starting to experiment with driving hobby servos with an Arduino is because the Robinson helicopter has a lot of analog gauges. And what I mean by analog gauges is gauges that are driven from sensors elsewhere in the aircraft that drive a needle on a gauge, kind of like this instrument right here, which is the engine cluster. So you've got some electrical readings, fuel readings, and then a few engine readings like the temperature and pressure of the oil, and then cylinder head temperatures. So these needles are driven by electrical signals that come from a sensor elsewhere in the aircraft, which basically puts a voltage onto these gauges and moves the needle like I'm doing with this pen here. Now these gauges are directly connected to the sensors through these bolts that come out of the back of the instrument. And because my simulator doesn't have any actual systems like the engine or the electrical system behind the firewall, there's nothing to connect them to and there's no readings to come from them. So what I have to do is somehow get the values from the simulator on the computer to move these gauges. And one of the ways to do this is to mount these servos behind the instrument face and then send them values through the Arduino to get them to synchronize with the values that are in the simulator on the computer. So the first thing I wanted to test was if I could move these hobby servos at all. So I connected it to the power and then connected the signal wire to the Arduino, and I set the Arduino to do a pre-programmed movement of just going to the left and then back to the right, and that's what you're seeing it do right now. But just moving by itself is obviously completely useless unless you can send it a value and get it to move to that value in the real world. So I set up this template with a protractor and then reprogrammed the Arduino to accept a value over serial connection and then move the needle to that value. So here you can see me typing in a value, and then as soon as I press enter, it moves the needle in the real world to that value on the protractor. This demonstrates that I can move the needle from the computer, and now I can move on to scaling other data to match the instrument face, and also hooking it up to the simulator data so that it moves automatically.